And so first and foremost, I'd like to break down my presentation into two parts. The first one is why I've chosen development as out of the linear model of innovation. And secondly, why I think utility patterns are a good way to evaluate innovation. And so the reasons for choosing development out of the linear model of innovation are quite simple for me. One is that it's historically consistent, and that the timeline of the linear model of innovation has shown that economists, academic researchers, and industry leaders have consistently used development in their linear model. And then secondly, for technological relevance, and really what I'm pointing out with that is that it's very unique. It's unique because on the left side you have scientific endeavors, and then you have development, and then business endeavors, where it's production and diffusion. And so I find that it's the epicenter between science and applied science. And Bronson and his economists in 1951 had a model that was very similar to the model that we were given for the competition. The idea of research and engineering as the sciences, development being the center, and production and service being focused on business. And so the OECD formally defined what development really is, and they said that the use of the results of fundamental and applied research directed to the introduction of useful materials, devices, products, systems, and processes, or the improvement of existing ones. And so the real thing that I really took it to heart is the words useful and improvement. And so I looked at statistics, or some way to measure those two words appropriately. I thought utility patterns would be a good way to evaluate that. And so what I did was I used some external data sources, and I came across this great source called the Bloomberg Innovation Ranking System. And they do something very cool in that every year they produce a list of the most innovative states, top 20. And they use statistics ranging from the Economic Bureau census to the US Patent and Trade Office. And they come up with these state profiles. And this one happens to be Massachusetts, which luckily enough is the third most innovative state from 2013. And they use statistics, which I'll cover really quickly, is STEM statistics, science and tech degree holders, utility patents, state government R&D spending, gross state product per employed person, 3-year change in productivity, and public tech company percentages. But the thing I was really interested in is utility patents. I've had a hunch that utility patents would be a good indicator for innovation. So utility patents, this is a spread and distribution of utility patents for that Bloomberg data set. And the most innovative states being around this side, and then the least being over here. And I just visually thought that the states that were more ranked higher in innovation had more in utility patents. But there was a flaw with this whole Bloomberg idea and Bloomberg ranking system, that it doesn't really tell you how significant utility patents really is, and it doesn't tell you the relationship between utility patents and the other variables. So I did what I thought I should do, and I did build a model. And here's a exploratory preliminary step. I just built a scatter plot matrix with score, the ranking score that Bloomberg provided us as response variable, and then the variables going right across. Nothing unusual really sticks out in my mind. Nice things I saw were like linear relationships across this side. And then STEM looking like it's factor, but it's not, it's ordinal. But I wanted to do a little bit more than this. Scatter plot matrix is just display or describe behavioral data, really, from a very high level point. So I went and built a model. I really wanted to know how utility patents push innovation. So this is a non-constant variance test, because I had a hunch that maybe I should test for normality or something like that. So this is called the Cook-Wiseman test. And this is the initial model, and with the alternative hypothesis being non-constant variance. And it tends to fail. And then for this one, so then I thought perhaps I should transform the variable so I could really come out with a really good model. And here's a transform using Box-Cox transformation. And so my analysis and my model ends up consisting of these variables. And the ANOVA table. The R-squared value seems to be quite high, and it's actually kind of almost seems misleading, but it's not that surprising because it's a very deterministic model. You punch. Yeah.
What is the dependent variable?
Score. Sorry.
Yes,
score. Yeah.
And that's for the Bloomberg.
Yeah. Yes. That is so. And so here we go. And then looking at the residuals, checking really if it's normal, really trying to rely on the model a little bit. But sorry. but it's just a model. I don't feel like the model is really explained to me. It really, looking at this ANOVA table, just helped me identify that maybe utility pattern is significant, and that some of these variables might be significant in addition. But what does it tell us? It doesn't really tell us much more than just that. So the first thing I wanted to tell myself, is utility pattern significant to score? It seems so. But with the combination of the regression model as a first step, and then using data visualization, I came up with this plot. And this plot is a lot to sink in, a lot of things going on, but I found it to be very informative. Score being on the left side, on this y-axis, and utility patterns being on the x-axis. The legend is consisting of science professional and STEM, just science-related variables. The dots here are the states, and this happens to be Massachusetts. So the trend right here actually is that it looks like it's up and right. As you go up and right, you get lighter colors. STEM levels are going higher, and the dots are getting bigger, you have more science professionals. And that makes intuitive sense. You would expect scientific degrees and technical people to contribute more to utility patterns and score. This is a bit of a regression line that goes through this. What's above the average is above average. Sorry, above the line is above average. Below the line is below average. Sorry?
What should this mean?
I believe it's just, I use lows. And so, but that really just matched my intuition. And it just made sense that science would help utility patterns, would help innovation score. So I want to go a little more detail and look into maybe perhaps financial data, which was included in the original model. Government research and development spending, and then this is gross state product per employed person. And here what's interesting is that it doesn't seem obvious. I have no idea what's going on in this. I don't really know, I can't see the obvious trend I saw with science. And I thought maybe it's the range, And so I did a log transformation on the range. I still don't get it. I don't know if colors are changing things. I'm not really sure what's happening here. And maybe, but I didn't instantly conclude that that was a bad thing. So maybe I just don't understand colors. So I went and chose, let's do another scale. Let's look at the size of dots, concentrating on government R&D spending. Again, the trend doesn't seem too obvious. Are they getting large? Are the dots getting larger or bigger as they go up and right? I'm not too sure. And then doing log transformation, it really looks like all the dots are just moving. And this makes me conclude and think that maybe government research and development or financial data is much more complicated. Maybe it's not included in my model. Maybe there's some external data source that should include and incorporate it. But I don't think it's a throwaway variable. So according to the ANOVA table, it does seem significant nonetheless. So understanding that financial data is complicated, but being convinced that utility patterns are important, what I did is I looked at my original, the data set that was given to us. And that data set consists, one of the sheets in the spreadsheet consisted of intellectual property stock cost, and then investment per industry. I took the ratios of two and tried to find which of those ratios were highest in each industry, ranging from data from 2011 to 2014. The industries that had the highest ratios ended up being computer electronic products, chemical products, publishing industries that include software, and then motion pictures and sound recording industries. Just to refresh everyone about what intellectual properties are, is that it includes things like trademarks, patents, and copyrights, which is why with copyrights, I'm not too surprised why this came up. And for me, my analysis of this would make me think that these industries have some kind of intellectual property momentum. Perhaps they can invest, perhaps they have the infrastructure to support more investment, or perhaps they use it more efficiently. And so, lastly, my recommendations to the state of Massachusetts are boiled down to 4 simple points. The first one is that I would recommend that the state of Massachusetts intensely evaluate government spending on research and development. It is not sure exactly how the results work. And because of that, I would secondly recommend that they should be conservative government R&D spending. Really be careful about how you budget it. Thirdly, consider evaluating the following industries that I showed before: computer and electronics, chemical products, publishing industries, and motion pictures. Because, again, these industries can support investments in potential growth. And then lastly, invest in institutionalized innovations such as education and related programs. And I guess that's time. Right? Yeah. Okay. All right, thank you.
the score? I mean, how is that score compiled?
Okay, so the score is compiled through Bloomberg's data set has these statistic variables, and they come up with a score. It's not completely sure how the score is ranked out, but my dependent variable was the score in itself.
Did it not mention how they works?
The weights, I don't know what the weights were specifically.
How is this score related to innovation?
So the way it's correlated to innovation is I was relying heavily on the Bloomberg system. And the Bloomberg system ranks it based on these statistics. And they rank it based on the state with the most innovation will have the highest score, the lowest score. And they look particularly in the science fields. They rely mostly on science fields.
But then why do you think that with this regression we are going to learn something about innovation? Because maybe what we are going to learn is the weight that Bloomberg has given to each one of the factors.
Right. So,
but the weight that they give is a subjective thing.
Right. So the way I was looking at it was I had a hunch for utility patents, and I wanted to find some kind of model to replicate that looked like they use utility patents. I guess with sorry, could you repeat that question?
Bloomberg takes these statistics, mixes the statistics in a way that we don't know,
right,
and takes the ranking as a summary of the statistics. If we do the regression of the score on these statistics, what we are going to learn is
the
weight.
Right, the weight. So I guess what I was working on was relying heavily on believing that the Bloomberg system was accurate.
Yeah.
That was my assumption. And then furthermore, what I didn't know was which variable was significant or not. I didn't know, I couldn't tell, I can't assume and know that utility patents are significant in their ranking system, and by how much. So that's what I wanted to find out. I wanted to find out which one of these were significant or were not. And that was my attempt at doing the regression.
What can you say about Massachusetts? I mean, some coefficients might be more predictive of innovation for one state and not for another, right? So is there any pattern that you observe if you remove Massachusetts or?
For Massachusetts, so one of the things I kind of wish I had done was really be able to plug in more Massachusetts data. I kind of want to stand across more continental things and really making I guess some of these suggestions could be applied to many other states. A lot more of the states rather than these Massachusetts specific. One hunch that I had, which I kind of wish I had used a little bit more, was sensing that chemical data might have been really useful. So the reason why I did this slide, this one right here, was that I think using the regression model as a way to convince myself that utility patents are significant, I thought, okay, well, utility patents are very related to intellectual property. And I thought, okay, so what industries might be important that way? And so I thought, maybe I can narrow down my analysis on this and find out whether or not Massachusetts has any momentum in these categories. But I tried to do it a little bit, but it was hard to collect pretty good data on Massachusetts intellectual property data. So I didn't really finish that.